Hello everyone. In this video, we are going to discuss about recursion in Java. We are going to see what is a recursive function. We are going to see the difference between the normal function call and recursive function call. And actually, you are going to see when a recursive function executes, right? The actual working of a recursive function. So first, you are going to see calling another function. So you can see the left hand side, void a is the function which is being used to call another function b. So you can see void a, that is a is a function, and inside the body of a you can see b, which is also a function. So when this line executes, what happens is it invokes the function which is written outside. That means you are calling from one function to another function by using the name. Now in other hand, when you say the recursive function, the function definition that calls itself is called recursive function. You can see here. Now here you can see void recur is a function, and inside the body of recur you can see another same recur word has been used. That means you are going to call the same recur function from inside. That means what happens is it is calling by itself. You are calling the function from inside. Okay, you are calling the same function from inside. You call it as recursive function. Now you are going to see the definition of recursive function. The process of solving a problem by reducing it to the smaller version of itself. That means you are going to solve a problem by calling the recursive function again and again. So whenever you call, every time it reduces the problem. That is, there is some changes. You can say x values is x is a problem. Second time it will be x minus 1, then x minus 2. It goes on till x minus n. So every time it reduces into the smaller version. Now we are going to see how to write a recursive function. Every recursive function must have at least two cases. Okay, first one is the base case and second one is the recursive case. So we are going to see one by one. What is this base case? It is also called as stopping case. It is the case that causes the recursion to end. So here only you are going to, so once it reaches its base case, the condition satisfies, you are going to end the recursion. In other words, it is a case whose solution is pre-known and used without computation. Maybe the value may be the least value like 0 or 1. When it reaches to that point, you know what the solution is and you are going to end the recursion. The second case is recursive case. It is also called as inductive case. It is the more general case of the problem we are trying to solve using recursive function. So every time, okay, this is a general case where you are going to solve it. Okay, every time you are going, whenever you call the recursive function, you are going to use this recursive case to call that function again, and then every time you are going to reduce it to the smaller version of that problem. Now you're going to see a sample example. Okay, you can see public class factorial is the class name, and you got three functions: public void run, public int compute int n, this is a parameter, and then public static void main string argues. Now we will start from public static void main. Here you can see the class name. You are creating an object for the class, so it is factorial ob equal to new factorial. So ob is the object which is created for the class factorial. Now using that object, with the help of that object, you are going to invoke run. So what happens here is it automatically transfers the control to void run. So in void run, you can see two lines: int result equal to compute 4 and then system of println result. So here you can see that you are using a variable of integer type, and you are going to call a function compute by passing the value 4 to it. So what happens here is automatically it invokes another function from this. So it will execute public int compute int n. That is, n value will be nothing but the value which is passed. So here it is 4. So n will be having the value 4. So once it gets inside the body of the function, you can see the first line. This is nothing but the base case. If n equal to 1. So once it is equal to 1, you're going to return 1. That means that is the least value, you know that, and you're going to stop. Okay, this is where you're going to stop. When the n value reaches 1, you're going to stop the execution of the recursion. Now else, suppose if the value of n is 4 and it is not true, so it go to the else part and it returns the value by reducing it by 1. So you can see n into compute n minus 1. So automatically it calls the function, the same function by itself, by reducing the value of n by 1. So second time it will be 3. So it goes on like that. Now you are going to see actually how it works. Okay. Now here you can see there is a program stack. You can see a box like this and you call it as a program stack. A program stack is nothing but a set of frames. You can see a lot of frames will be one above the other. Okay, so for example, whenever you use a stack, it uses the algorithm like if you last in first out. That means whoever comes last will be the person who will be going out of the stack. Say for an example, you can say you're going to submit your records for correction. Okay, the person who keep the record at the last will get the record back first. Okay, so whoever keeps the record on top, okay, will get the record corrected first and then it will move on. So it'll be like the first person who keeps the record will be getting the record last. So it uses the algorithm last in first out. So you can see that when a new frame is created, it will be placed on top of the stack. So whenever you create a new method which has been called, it automatically creates a frame and it will keep it above that. And whenever you return the stack, what happens? It removes the method frame. So whenever you remove it back, it removes the method frame from the stack top. So always it will start. It will push it in front. Okay, that is push it inside the stack, and the frame will be kept above the each frames. And when you remove it, the top portion of the frame will be removed out. So you are going to see one by one. So once you know that run has been executed, it in turn invokes compute 4, right? So this is what happening here. So compute 4 will be invoked. So what happens is it will keep a frame, that is it forms a frame on top of the frame which is already available. So compute 4 will be the stack which has been created, that is a frame which has been created, and the n value is 4 now. Now what happens here, it will compute this value, the condition will be checked, here it is false. So it goes on to the else part, here return n into compute n minus 1. So what happens is, so it stores that n value 4 into the stack, and also it calls the function by reducing the n value by 1. That means it will be compute 3. Okay, so next time what happens, compute 4 in turn invokes compute 3. So what happens here is, it will create another frame above the compute 4 and compute 3 will be stored. Now the n value is 3. Now it checks the condition is false, it goes on to the else part. Here again you can see n into compute n minus 1. So in turn it calls the compute function by reducing the value of n by 1. So here you can see compute 2 will be called, right? It creates a frame. So compute 3 will call compute 2 and then it creates a new frame here, and then again it checks the same routine work will be done. Now the n value is 2, the first condition is false. So go to the else part and checks whether the n value is that is you are going to compute call the compute function again by reducing the n value. Again now what happens is n minus that is 2 minus 1 is 1, which will be called. So compute 2 will invoke compute 1 and the stack will be filled. That is means you are going to create another frame, okay, with the value 1. N value is 1 now. Now what happens, it enters the function. Now if the condition is true, what happens, it returns 1. So here only you are going to stop the recursion, right? You are going to stop. So once it is stopped, what happens is it will remove the values one by one. So what happens is compute 1 will be returned back. Okay, it returns compute 1 and then automatically it resumes compute 2. So for illustration you can see how the values have been given in the stack. It will be like 4 into 3 into 2 into 1. So the innermost bracket is 1, that will be returned. Okay, so what happens when it returns, it will multiply with the previous value. This is what is going to happen. So the second time you are going to remove the compute 2. Okay, so you are returning compute 2 and then it resumes compute 3. So automatically it will multiply the value with the previous value. Now third time it will be compute 3 which has been returned and then it resumes compute 4. Okay, then the last time compute 4 has been returned and then it resumes run. Now what happens, the value finally stored after multiplying, the value finally stored is 24. That will be returned to the function run. Okay, now what happens, the value which has been written will be stored in the variable result here. Okay, so once the result has been found, then you are going to display the value which is stored in result. So the screen which will be the terminal window will display the value 24. So this is how the recursion function works. So hope you understood this video. We'll meet you in the next video. Till then, thank you.